So for our first example here, the color A shown slides along the rotating rod OB. The angular position of the rod is given by theta equal to 2/3 pi t squared radians. And the distance of the collar from O varies as r equal to 18 times t raised to 4 plus 4 inches, where t is measured in seconds. Now determine the velocity and acceleration vectors of the collar at t equal to 0.5 seconds. The given coordinates of the collar are polar coordinates. Therefore, it will be very wise to also analyze this motion using the polar coordinate system. So we start our solution by first determining the values of the polar coordinates of our collar A and their first two time derivatives at t equal to 0.5 seconds. So from the given r and theta expressed in terms of t, so kukunin lang natin yung first and second derivatives nila with respect to time. So after that, again, we will simply substitute the time t equal to 0.5 seconds. So now we have these values. From the equations we have previously derived on our previous video, the velocity components can now be calculated. So, isa-substitute lang natin yung mga values na to doon sa equation natin for our velocity. For the radial component, that will simply be equal to our r dot at t equal to 0.5 seconds. Therefore, we have 9 inches per second. And then for the transverse component naman ng velocity natin, that will be equal to the product of our r and theta dot at t equal to 0.5 seconds. So multiplying those two values, we have 10.73 inches per second. Therefore, the velocity vector of the collar at t equal to 0.5 seconds is equal to 9 e sub r plus 10.73 e sub theta inches per second. So in this figure, we can see the velocity vector that we have obtained. So again, yung radial component, ito yung direction niya. Huwag kakalimutan ha. So that is parallel to our radial line. So that is again 9 inches per second. And then yung transverse component naman, that is perpendicular to our radial line, and also perpendicular to our radial component. So it will be pointing towards this direction. At t equal to 0.5 seconds, ito yung position ng particle natin. So yung r component or yung length ng radial line natin, that is 5.125 inches. And then yung polar angle naman natin, that is equal to 30 degrees. Okay, so equal din yan sa 0.5236 radians. And then, papunta naman dito yung magnitude ng velocity natin. Kung kukunin nyo yung direction ng magnitude ng velocity na to, so you will take the arctangent of the two components of our velocity. So most probably, yung makukuha nyo angle, that is with respect to one of the components, okay? Hindi siya with respect to the x-axis. So if you want to get the angle with respect to x-axis, kailangan mo pang i-add yung polar angle natin dito. Be careful lang, no, sa direction. Okay? So ngayon naman, yung components ng acceleration vector yung kukunin natin. We will simply substitute the values here dito sa na-derive natin na equation on our previous video. So ilalagay lang natin yung mga values na to. So for the radial component of our acceleration, that is equal to r double dot minus r theta dot squared. So substituting the corresponding values, that will be equal to 31.52. And then yung transverse component naman, so that is equal to 2r dot plus r theta double dot. So again, just substitute the values here. Okay, so that will be equal to 59.17. So now our acceleration vector is equal to 31.52 e sub r plus 59.17 e sub theta inches per second squared. So this result is illustrated in this figure. So we can see here the components of our acceleration vector along the radial and transverse direction. So papunta naman dito yung magnitude ng acceleration natin. Again, if we are going to determine the direction of the magnitude, so kailangan natin kunin yung angle beta na to. Yung gagamitin nyo is arctangent of the transverse component divided by the radial component. So in this case, yung angle beta natin will be from the radial component. Okay, so with respect to AR siya, hindi siya with respect to the x-axis. Again, if you want to determine the direction of our acceleration with respect to the x-axis, so kailangan nating i-add yung polar angle theta natin dito. Okay, so again, be careful sa direction ng vectors natin. Okay, so for our next example here, the robot arm is programmed so that the point P traverses the path described by r equal to 1 minus 0.5 cosine of 2 pi t meters, and then theta equal to 0.5 minus 0.2 sine 2 pi t radians. So yung tanong, what is the velocity of P in terms of polar coordinates at t equal to 0.8 seconds? So again, this is a no-brainer since yung given and then actually yung required sa problem is naka-polar coordinates. So yung gagamitin natin dito is the polar coordinates system. So again, itong dulo daw ng robot arm natin, itong point P will traverse this path. So yung required is yung velocity vector at t equal to 0.8 seconds. Now from the formula of our velocity vector in terms of polar coordinates, we first need to determine these values. So we need the first derivative of r, and then yung r, and also the first derivative of theta, again with respect to time, at t equal to 0.8 seconds. So galing dun sa binigay sa problem, yung first derivative ng r natin with respect to time, that will be equal to pi times sine of 2 pi t. And then, yung first derivative naman ng theta natin, that will be equal to negative 0.4 pi cosine of 2 pi t. Again, we need to determine the velocity vector at t equal to 0.8 seconds. So, we need to substitute this 0.8 into our time here. So, now, we have these values. So, recall na kailangan din natin kunin yung value ng r or yung length ng radial line natin at t equal to 0.8 seconds. So, isa-substitute lang natin yung 0.8 doon sa equation ng length ng radial line natin. And then after that, isa-substitute lang natin yung mga nakuha nating values dito sa equation ng velocity vector natin. Now, we have the velocity vector at t equal to 0.8 seconds equal to negative 2.99 e sub r minus 0.328 e sub theta meters per second. Now, as you can see, yung components ng velocity vector natin is negative. So, in this case, yung direction ng radial component ng velocity vector natin will be pointing towards the direction of O or yung origin natin. Kasi again, recall that the radial component is normally pointing away from our origin. So, kapag negative yung nakuha nyong sagot, that will be in the opposite direction. Therefore, pointing towards the origin. And then similarly, since the transverse component is also negative, yung direction niya will be towards this direction. Okay, so recall that normally, yung transverse component natin, it is pointing towards the direction of increasing theta. Therefore, kung negative yung value na makuha natin, that simply means it is pointing to the opposite direction. Therefore, pointing towards decreasing theta. So, papunta siya dito. Okay, so that's it for this video, guys. Again, practice lang. Solve na mga problems. Okay? So, see you on the next one.